Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from group 2 and today we will explain the material about addition, subtraction and multiplication of matrices. And before that, I will introduce ourselves. My name is Devi Nursaida Putri.
Hello, my name is Hafiz Al-Farisi.
Hello, my name is Muhammad Faisal Pratama.
And now I will explain briefly about matrices, and then after that I will explain about addition matrices. The important rule to know is that when adding and subtracting the matrices, first make sure the matrices have the same dimension. They must have the same number of rows and columns. In other words, you can add and subtract 2 by 3 with a 2 by 3 or 3 by 3 with a 3 by 3 because matrix A and matrix B must have the same dimension. However, you cannot add 2 by 3 with a 3 by 2 because they have a different dimension. For the examples, matrix A and matrix B have the same dimension. It's 2 by 2 with 2 by 2. It means 2 rows and 2 columns. So we can add this matrix. For this matrix, we can see matrix A and matrix B have a different dimension because that we cannot add matrix A and matrix B because matrix A have 1 by 2 and matrix B have 2 by 2 and they are different. And now I will explain about addition matrices. Rule to follow in order to add matrices: you can add elements in the same rows and same column. Here we have two matrices. The matrix A is 2 by 2 and the matrix B is a 2 by 2 matrix. Because they have the same dimension, we can add them. Here's how we would add matrix A and matrix B. 2 plus 5, the sum is 7. 6 plus minus 1, the sum is 5. 4 plus 4, the sum is 8. And 3 plus 2, the sum is 5. And the answer from the sum of the matrix A and matrix B is 7, 5.
I will explain about matrix subtraction and matrix combination. Example: matrix A means matrix B. 3 minus 0 is 3. 1 means minus 3 or 1 plus 3 is 4. 2 minus 4 is minus 2. 4 minus 5 is minus 1. Next, matrix combined. Matrix A means matrix B plus matrix C. 2 means minus 1 plus 4, that's it. 2 means minus 1 plus 4. Next, 6 means 2 plus 5. 6 minus 2 plus 5. Next, 5 means minus 5 plus 2. 5 means minus 5 plus 2. Next, 3 minus 3 plus minus 9. 3 minus 3 plus minus 9. Next, 2 minus 1 plus 4 or 2 plus 1 plus 4 is 7. 6 minus 2 plus 5 is 9. 5 means minus 5 plus 2 or 5 plus 5 plus 2 is 12. 3 minus 3 plus minus 6 is minus 6. So, the result of combined from the matrix A minus B plus C is 7, 9, 12, minus 6.
Okay, now I will explain about matrix multiplication. Matrix multiplication falls into two general categories. First, scalar, in which a single number is multiplied with every entry of a matrix. The second, multiplication of one matrix by a second matrix. Okay, I will explain about scalar first. In the scalar variety, every entry is multiplied by a number called a scalar. In the following example, the scalar value is 3. In here, I have a scalar. 3 contain the element 5, 2, 11, 9, 4, and 14 equal 3 multiply 5, 3 multiply 2, 3 multiply 11, 3 multiply 9, 3 multiply 4, and 3 multiply 14. The sum is 15, 6, 33, 27, 12, and 42. In addition to multiplying the scalar matrix, you can multiply one matrix with another matrix. You can multiply two matrices if and only if the number of columns in the first matrix equals the number of rows in the second matrix. In here, I have a matrix A and matrix B. This section is a column, and this section is a row. Now, this matrix A have a 4 column, and matrix A have a 2 rows, and this matrix B have 3 columns and 4 rows. In this section, the matrix can be multiplied since the number of columns in the first one, matrix A, equal the number of rows in the second matrix B. So let's try the other example. In here, I have a matrix A and matrix B. In matrix A and matrix B have same number, is 2 column and 3 rows. This section, matrix A and B can be multiplied together because the number of columns in A not equal to number of rows in B. In this case, the multiplication of these two matrices isn't defined. If you still don't understand, let me show you another example. In here, I have a matrix C and matrix D. In matrix C, have 2 columns and 4 rows, and matrix D have 5 columns and 3 rows. In this section, matrices C and D can be multiplied. The same applies to matrices A and B, because the number of columns in C not equal to number of rows in D. In this case, the multiplication of these two matrices isn't defined. Okay, then here is the matrix A and matrix B. And my question is, can the two matrices below be multiplied? So let's try it. In matrix A have 4 columns and 2 rows. In matrix B have 4 columns and 3 rows. Since the number of columns in matrix A doesn't equal the number of rows in matrix B, so the multiplication of A and B is undefined. So, what are the dimensions of the product matrix? The product matrix dimension are rows of first matrix multiply column of the second matrix. In here, I have a matrix A and matrix B. In matrix A have 4 columns and 2 rows, and in matrix B have 3 columns and 4 rows, and the product is 2 row and 3 column. We can see that from matrix A and matrix B can be multiplied because they are the same row and column.
Okay, so how do we multiply two matrices? In order to multiply matrices, step 1, make sure that the number of columns in first one equals the number of rows in the second one. Step 2, multiply the elements of each row of the first matrix by the elements of each column in the second matrix. And the last step, add the products.